Alright everybody, just wanted to record a quick stats video. This is free response problem 1. It says a researcher believes that treating seeds with certain additives before planting can enhance the growth of plants. An experiment to investigate this is conducted in a greenhouse. From a large number of tomato seeds, 24 are randomly chosen. 2 are assigned to each, of 12 containers. One of the seeds is selected and treated with the additive. The other seed serves as a control. Both seeds are planted in the same container. The growth in centimeters of each of the 24 plants is measured after 30 days. The data was used to generate the partial output shown below, and by below they mean the next page. Graphical displays indicate the assumption of normality is not unreasonable. Okay. Construct a confidence interval for the mean difference in growth in centimeters from untreated and treated. Okay. So you got to construct a confidence interval. So I would start by saying you have a 2-sample t interval. 2-sample because you have control and treatment. T because you have a quantitative variable and you're finding means. And the standard deviation of the population so this is the mean, and what are they looking at? The mean difference in growth. So here's the treatment, mean growth from treatment and mean growth from control. Alright, so that's the name part. Now you got to do the conditions. Remember, for a t interval there are 3 conditions we want to talk about here. The first condition is random samples stated in the problem. Assume independent. One sample does not affect the other. And graphical displays are said to be, so notice it says that the graphical displays indicate the assumption of normality is not unacceptable, are said to be approximately normal. Okay, now the math. So even though they do give you this difference, I would still just use the control and the treatment, because remember, like, you may not have this difference on the AP exam, so but you'll definitely have the control and the treatment. So you want to say confidence interval equals x bar 1 minus x bar 2 plus or minus the t-stat times, well, square root of s over s1 squared over n1 squared plus s2 squared over n2. This should be equals x bar 1. I'll just call 1 the treatment, so 18.004 minus 15.989 plus or minus, we'll come back to the t-stat. Standard deviation of the first one, standard deviation of the treatment, 1.175. 1.175 squared over n1 is 12 plus s2 is 1.098 squared over 12. Confidence interval equals 18.004 minus 15.989 plus or minus. Now to get this t-stat, we'll need to use our table. So let me go grab mine. Hold on one second. So when you're trying to find your t-stat, we know we have degrees of freedom. 12 plus 12 is 24. 24 minus 2 is 22. And since it's not given, we're going to assume a 95% confidence interval. Okay, so notice we want the t-stat. So the degrees of freedom, well, sample size is 12 plus 12. 24 minus 2 is 22. And it doesn't say what confidence level. We'll assume they want 95%. You can make that assumption. So 95% and 22 should be this column 2. Let me zoom in here. 2.074. So go ahead and put 2.074 as your t-stat. And just copy this down here. Okay, now this goes into the calculator, and the confidence interval is, and you may just want to say here df equals 22, and the confidence interval. So let's come over here to the calculator. Let's go stat. Let's go test. Let's go to sample t interval. X bar 1 was 18.004. Standard deviation is 1.175. Sample size is 12. The other one is 15.989. Standard deviation is 1.098. Still 12. Confidence level is 0.95. Not pooled. Click calculate. Confidence interval is from 1.0520, comma 2.9780. 2.9780. Right? I may now draw the picture. Excuse me, sorry that got switched. Time to draw the picture. So the picture says, sort of come over here, 1.052, 2.978, 0.95. So we are 95, now you're at the sentence, we are 95% confident that the true mean difference in centimeters between treatment and control is between, it's between what and what? 1.052 and 2.978. Is between 1.052 and 2.978 centimeters. That's part A. Now part B says, based only on the confidence interval, is there sufficient evidence to conclude there is a significant difference? Justify your conclusion. So, well, if you think about it, if you think about part B, what? That the mean treatment minus mean control equals 0, and the alternative would be that the mean is greater than the mean control. Now, the probability 0, well, 0 is outside this 95% interval, so the probability must be what? Must be below 5. So since 0 is not in the interval, the p-value of 0 must be below 0.05. Thus, we reject H0 and conclude that yes, there is enough evidence. Conclude there is enough evidence to say there is a statistically to say that there is a mean difference between treatment and control. So because 0 isn't in the interval, The p-value of getting a 0 must be less than 0.05. We know 0.05 is the significance level default, so therefore we're going to reject the null and conclude that there is sufficient evidence, there is significant evidence.